Let us continue stretching our brains ever bigger with our next speaker, Charlotte! Everybody bring it again! Woo!
Hi everyone, I'm Charlotte. I'm a React Native tech lead at Theodore Apps, and today we're going to talk about flows. Most of our apps have flows, like an onboarding or a Tone payment. Flows are a succession of pages where you know where the user is going to go next. They are defined in a predefined order. Most of our apps have flows, but when they grow up to be more complex, it's very easy to end up with unclear code. Last year, when I joined a new project with an already implemented flows, I was tasked with the simple task of simply adding a page within the flow. But the code was so complicated that I couldn't even do that. I was the only developer arriving on the project. I like guidance. So I spent days digging within all the pages, trying to figure out the flow as a whole, trying to decipher all the navigation paths. And even after all this time, I wasn't confident about adding a single page. Fast forward a few months, and I'm tasked with developing a new flow. So this time, I was determined to do it right. This is the story of our reflection towards building flows that are as clear as possible. Today, we're going to use the power of state machines to enhance React navigation to handle even the most complicated flows. Before we dive in, let's properly define what a flow is. A flow is a succession of pages, like an onboarding, where you know where the user is going to go next. Contrary to regular navigation, where the user can just decide where he wants to go to. With flows, the user doesn't have to make a choice. He just hits the next button every time, and you can know in advance which page is going to be the next one. The flow I had to implement looked somehow like this, only more complex. You don't have to read it through to understand it has lots of conditions, lots of intelligence in it. It's still a flow. With certain parameters, you can still know where the user is going to go next in advance, but it just has a lot of logic. And the problem is, if you just simply use regular page-to-page navigation for this kind of flow, it can get really hard to get a good overview of the flow as a whole. If you simply define your pages this way, like we normally do, you define your pages, but you don't define their order. To know all the possible pathways, you have to dig inside every single page and look at this conditional navigation. So how can we solve this? How can we write code that screams at us, these are all the possible pathways? That reassembles all the logic, all these possible paths together in one single place. That offers new developers a good overview of the flow without requiring them to dig inside every single page. That's the problem we're going to try to answer today. Before we talk solutions with specific tools we tried, let's abstract ourselves away from all possible limitation. Let's imagine in a perfect world what the ideal solution could look like. I have two criteria. First, get a good overview of the flow in one place. And second, remove from the pages the responsibility of knowing which page is the next one. So instead of navigating inside cart review to this specific page, we'd like to have a method like go to next step. This way, cart review doesn't have to know its position inside the flow. So what could be our first approach? This go to next step methods, it may seem familiar to you. It actually looks a lot like a state machine. Let's define what a state machine is with a simple traffic light example. We could define a traffic light system with a state machine. A state machine has states, in our case colors, and transitioning events to transition from one state to another. Inside your state machine, you define both the system and its current value, and you can send a next event to transition to the next state. This way, all of your logic is handled only in one place. So, what does this mean for our flows? Our states could be our pages, our steps. Then, when the user hits the next button, we could send the next event and transition to the next state. This would look somehow like this. We define our state machine here with all of our steps, all of our pages, A, B, C, D. And inside the A step, we define this next event. And when we hit next, we are going to transition to the next state, to the next page, B. When we transition, we are also going to perform navigation. We are going to navigate to the next page to make sure we see it on the screen. This way, inside our A page, we can simply just send the next event, and A remains unaware of its position within the flow. This is a great solution, but it actually has a very big problem, that our state is duplicated between two. Our states, which steps are we currently focusing on the flow, is split between two states. Obviously, the state of the state machine, which is our source of truth. It tells us where we are within the flow. And also the navigation states, which determines which page is currently focused on the screen. When we send the next event, we change the state of the state machine, and we have to make sure we update the navigation state as well to display the correct page on the screen. If we forget to synchronize these states, we have a bug. We fall out of sync. So this implementation is very bug-prone. If we just forget to navigate within the state machine, we have a bug. So instead, we went on to our second approach, a more declarative one. Instead of defining our pages this way inside a traditional navigation stack, we defined it this way. From the value of the state machine, we defined our pages. So instead of defining a stack, we simply return the correct page. This way, we don't have to navigate manually anymore inside every single event of the state machine. This is a little bit better, but there is still some configuration that we really should not forget, otherwise we have a bug. And also, we lose transition animation. We don't have a stack anymore, we just return the pages. And React Navigation actually never tells us to do something like this. So we went on to our third and last approach. When one of our colleagues asked us, have you thought of building a custom navigator? Turns out you can build your own custom navigators tailored for your own specific needs. This way, we could merge our two states into one. We could build one navigator that could have a state with the shape of a state machine. So let me introduce you to the Flow Navigator. To show you its API, I would like to use a simple payment flow example that has only 3 pages. Remember our 2 criteria. First, we want to get a good overview of the flow in one place. So this is how you would use the Flow Navigator. It really looks just like any regular other navigator. Only when you define your pages, you also define their order. So here you're saying, I have cart review, then payment, then success. This way, you have in one single place the order of the flow. Then, second criteria, we want to remove from the pages the responsibility of knowing which page is the next one. So inside cart review, you could simply call this go to next step method. The way that this works internally is simply through an index, which states which page is currently being focused. Initially, it's equal to 0, so initially we're on cart review, and when you call go to next step, you simply bump the index and move on to the next page in the order, so payment. This is our Flow Navigator, but we have a new functionality now. We want to be able to handle conditional steps. We have now this new document page that has to be displayed only once to each user. This could be implemented somehow like this. Here I define this Boolean has to sign, currently using Jotai. And according to its value, I'm declaratively adding or removing the document signing page. So initially, this value is truthy. So document is within the stack. So when I call go to next step from cart review, I move on to the second step, document signing. Then inside document signing, when I click on the go to next step button, before I call the go to next step function, I'm going to switch off this Boolean to false. This triggers a revender on this component. So here we have has to sign false, and we're removing the document signing page from the stack. We called go to next step, so we moved on to the next page within the flow, payments. And if on payment we call go to previous step, as document signing is not in the stack anymore, we're going to go back to cart review. This is simply how it works. But you may want to have several conditional steps. If you do, you may group them together simply using groups. And this is our solution. It solved lots of our problems of architecture, but it still has some limitations. First, the most important one is that we can't actually really see all the possible pathways within the flow. Here, you know that you have 3 conditional pages, B, C, and D. But you can't really know all the possible pathways at any given time. You don't know the value of these flags. So here, from this view, you can't tell whether it's possible to navigate from B to C, for example. If we wanted to solve this for more complex cases, we could imagine adding another API that's closer to a state machine. If we had a configuration like this, it now becomes clear that from B, it's not possible to go to C. You can only go to C from A. The second big limitation we have today is that it's currently possible to use the Flow Navigator with React Navigation. We haven't built it for Explore Router yet. And this is all I wanted to share with you today. I hope that you've enjoyed this reflection on architecture and responsibility. And next time you see some logic that's spread throughout your app that could use a state machine, I hope you think of Xstate. Also, building a custom navigator is very easy, and you can build it for your own specific needs, whether it's logic, just like with the Flow Navigator, or whether it's design, like the bottom tab has a different design than the drawer. Big shout out to the people at Theodo Apps who helped building this Flow Navigator. Here is its code if you're interested in checking it out, and here is the code of the first 2 examples. Thank you so much.